All right. Thanks for joining us today, everyone. We have a special treat for you. As two industry veterans who spent a lot of their career as users, we'll discuss gas turbine repair planning, creating value every time. Our presenters today are Greg McCauley and Peter Sobieski of TRS Services. My name is Scott Schwieger, and I'm the editor of Combined Cycle Journal, and I'll be today's host and moderator. First off, I'd like to give you an overview of the WebEx control panel in case you run into any issues during the presentation. If you run into any audio issues, just click on that audio icon and you'll be able to change your speakers or call in. And then please ensure that you have open the WebEx participant and chat windows by using those associated icons at the bottom of your screen, and they'll pop up in your side panel. Send questions for the presenters to me via the chat, and I'll send them through to Pete and Greg, and they'll try to answer them in stride during the presentation, so keep them coming. We're going to try to make this as interactive an event as possible, but we'll also have some time at the end of the presentation for Q&A. The goal of today is to learn how to save time, money, and minimize risk, as well as ensure your repairs are performed correctly and transparently. Greg and Pete will share their recipe for repair success, from focusing on lifecycle costs through execution and the resulting advantages to end users. Greg and Pete will share best practices from their many years running Calpine's renowned turbine maintenance group. Now, Greg is the president of NGM of TRS Services, whose shop is located in Houston. And Pete is the lead operations advisor and serves on the TRS board of directors. They've both been in the power generation industry for more than 30 years, have vast experience with all frame units, and we are very happy to have them here today with us. So now I'll pass it over to the presenters.
I want to, first of all, thank Scott for helping us or allowing us to communicate, like he said, some best practices, as well as just to be able to answer any questions that you have about life cycle costs, repair planning, etc. What we want to talk about today is what does repair planning mean? Some typical repair planning methods. And what we feel are the 5 key ingredients to better repair planning, and as I've mentioned before, to answer any and all questions that you may have. We can read, a little bit further on our background, but like Scott mentioned, we've been in the gas turbine or turbo machinery repair domain for over 30 years. I celebrate 31 years on Friday of this week, and Pete is right there with me. So briefly, who TRS is. We provide turbine component repair, new parts manufacture, and consulting services that reduce downtime, minimize total cost, and enable new opportunities for top operators and manufacturers and other participants in the energy sector. We don't just perform repair of turbo machinery components, but we take a 3-pronged approach that allows us to take a bigger picture look of all things component repair, as well as turbine maintenance and the repair of said turbines. The benefit of taking this 3-pronged approach is reduced downtime for our customers, lower risk for our customers, lower costs, and then less hassle for our customers. So taking a more holistic or more detailed approach to component repair and as it impacts the rest of the operation, is producing better results for our customers. So what in the world do we mean when we say repair planning? Is it just simply the task necessary to get your parts that need repair into a shop and then have said repairs performed to the parts? We believe it's a little bit different in that we believe it's the process where we determine the if, why, how, where, and who, and when we do what to our rotable assets. So Pete's going to talk through some of the typical methods of repair planning that can be messy.
Yeah. So typically people have done what they've always done just in time, tracking through a spreadsheet, sometimes using forecasting tools. However you make your sausage, there's 5 essential ingredients we guarantee you that will improve your repair outcomes. And it's looking at some other thoughts when you're going through the process, when you're figuring out what are you going to do with the parts that come out of your engine. So go ahead and lead off, Greg.
Repair planning produces better results, and it makes perfectly good sense. And like I mentioned before, we hold that there's 5 essential ingredients to a successful repair planning program. And then what they mean to you if you include all 5 key ingredients. These 5 essential ingredients include focus on life cycle cost, know your parts, have a fallout plan in the case a part is not repairable, choosing the right repair partner, and then starting your execution early. Including all 5 key ingredients, again, can produce a shorter repair interval. You can save money and lessen the hit to your budget. We can experience fewer unexpected errors, the more detailed of a plan that we have. And then actually, it may be a little bit counterintuitive, but it can be less hassle if you have a robust repair planning process at your site or in your business. So again, the first key ingredient is a focus on life cycle cost. So what is life cycle cost? And what is a life cycle cost analysis program? We hold it's the most important step in a repair planning program. So our definition of life cycle cost is all the costs to maintain the operability or the ability of the part to perform as designed, divided by the life of the part. It's typically given in hours and in cyclic duty units or peaking units in thermal cycles or starts on the part. So what parts deserve a life cycle cost analysis program? We hold that rotable parts and then single-use parts with different lifespans. So you're able to compare life cycle cost to life cycle cost. Who should complete a life cycle cost analysis program? Everyone focused on maintaining or reducing the cost to maintain their assets. I once heard that major maintenance on your turbine generator sets is the second most expensive part of owning and operating a gas turbine or a power plant. That may not be true in all cases, but again, it's a significant cost that the customer bears to keep the turbines running. And then when should I perform a life cycle cost analysis? There's really three times when this should be performed. Before a new component purchase or at the start of a repair planning process. Anytime there's new data And then when trouble arises, as we will show in a couple of life cycle cost examples, they were really born by when trouble arose, early in the life cycle of one particular model of a turbine that was operated in our former life, so to speak. First example I want to use is an example of a transition piece, or actually Pete is going to, since this was one of his babies, go through this example.
Gene, so basically we had transition pieces. They'd make maybe 4,000 hours before we had to pull them out of the engine due to distress on the parts. And why it's important is you look at where you're going to put your engineering resources. What are you going to do to make an engine make life? So in this particular engine, every 4,000 hours, we were having issues. Parts may be scrap or repairable. And then when we went to management to champion, hey, we need to develop a new repair. We need to develop a new part. We need to do something. This comes down to showing your cost-benefit analysis of what the plan is. These parts may be inside a long-term service agreement. They may be outside. It's kind of immaterial because of the fallout and whatnot. So you look at what it costs to buy the part new. You look at what it takes to repair. Is it repairable or not? And do you have fallout? And did you have consequential damage? Which a lot of these parts cause consequential damage. So owning that part's not only the repair, and then it's what does it do to the engine? Is it causing you to do outages earlier? Is it adding the amount of outages and that cost, or what? So when you're looking at where you're going to put your resources, what you're going to put your time and effort, you're looking at that engine, how many hours do I get out of it, and which parts are preventing me from making that, and how much does it cost me per hour of operation to do something. This resulted in us going to a third party to develop a new part, which it did cost more than the OEM part inside of the LTSA. There was more repairs, mostly because the part lasted a lot longer. So we looked at our outage window of going every 4,000 hours to every 32,000 hours, and then having a repair. We didn't have any fallout at that time, so parts didn't fall out. And then the other was incremental testing, proving out the repairs. We knew in the future as we repaired something new, it was going to take more development to figure that out. So in this example, it was pretty easy to make a case to management to champion this project and go after it. Life cycle cost, the old method cost us $300 an hour just to run. If you think about what you pay an OEM or some of these other things, dollar an hour deals or whatnot, this adds up quickly. So that moved from a $300 an hour part to being a $31 an hour part. And basically in the past, we looked at every part in that engine this way. There was a set chart, history, what do we normally do? Luckily for us, we had a lot of data since we had a lot of engines, but it tells you where to focus your resources to get those engines to make life, and then what's the cost of owning that engine, which the repair part's one part of it. And then we have another example after this one. All right, so I answered the other, looking at Scott's questions, we answered what is the other? It may be repair development, it may be extra inspections, doing bore scopes, things along those lines, which we knew were in there, we put against the cost of owning that part at early stages. So first time a new part you put through an engine, you're going to have these costs, so we bookkeep it and whatnot. And then this question, what's the example of a single-use part? This is this example right here. So we'll go through example 2, and that'll answer the other question. So here we go. We had basically, these are ring segments. You could run them once with a pretty good chance of making your 24,000 hours. We were doing repairs, and when after repair, due to distortion in the parts, the ability to hold tolerances, just a whole host of things, there was a lot of issues with forced outages. Side seals would come out along the horizontal joints. We would burn through, have pieces going through, cause second stage blade damage. There's just a lot of things. So option 1 what did it truly cost us? Hey, you buy the part new, we had a repair cost, and then we had downstream damage and a cover pull. So the other, in this case, on option 1 is the cover pull. Option 2, just buy brand new every time, don't repair, don't have any issues, but you know, it's $100K. So that results in a $4 an hour cost of ownership. And the last one was, there's some latest and greatest parts, but they had a higher cost. They had a repair, and then they also had fallout. So when you looked at the cost of going to upgraded parts versus buying old style and running them, the best option was buy the old style, run them, and throw them in the trash. So this is a different kind of case. And then the other question we had on these, are these repairs based on equivalent hours of operation or failure? And these calculations are done based on the hours of operation on the parts. I mean, the fallout will change how many operating hours you have, so it does affect the math in here. If the thing only lasts 4,000 hours, a new part divided by 4,000 versus dividing by 48, the math is there. So.
An additional question for life cycle costs in option 1, are we assuming consequential damage during each interval? In that example, no, we were just including the cost to repair or to replace the parts prematurely. So every 4,000 hours, we were putting a brand new set of parts in the machine, and thus supporting a much higher life cycle cost because the denominator in this case was so low or so small. The second key ingredient that we recommend you adding to your repair plan is physically knowing your parts. So you might ask, what does this mean? Know your parts. There's a lot to know, or that we can know, about our components and on our engine assembly. We've talked about life cycle cost, hours since the last repair, starts since the last repair, the physical appearance of the component. The photo here is of a row 3 vane. There's a lot to learn about the type of cracking that we see or other issues that we see on the part, the color of the coating if the part was coated, how intact the coating is, the repair history of the part, what was done to it, what treatment, what methods were used. The more knowledge that you have around your parts, be it data or just anecdotal information, the more informed or better repair decisions you can make. OEM part expectations. There's a published life for every component in a turbine. So know what those are, compare them to your expectations as well as your actual experience, and then make decisions based on that potential delta. Your personal experience with a similar part, with a different at a different plant, or with a completely different owner, and then lastly, industry experience with the parts in your machine. So communicating with peers and with the manufacturer on as far as their experience and your experience can produce value. The third key ingredient we recommend we have is having a fallout plan. And you may ask, what is fallout in this case? Fallout is when a part cannot be repaired and added back to the set. It typically pertains to sets of components, but that's not always the case 100% of the time. So what parts should I focus on in terms of replacing fallout? Primarily, you're dealing with rotating parts, but that's not always the case. There are instances, let's say you have a row 2 vane, in a machine, and you have a leading edge issue. That part may not be repairable. So then you have to you ask yourself, where can I find another vane segment? Because you can't obviously run short one segment in a machine. You can't run short one blade in a set of blades in a machine. So, again, when we talk about contingency planning, have a plan for every set of parts that are going out for repair. How can I predict fallout? The more robust life cycle cost analysis program that you have, you'll be able to obtain and use more data to be able to predict what your specific fallout rates are, and then also OEM and peer external rates. By that I mean, what is the OEM experiencing when they're repairing parts? And then what are your peers doing and or other repair shops? What is their experience? Again, the more data, the better off our repair plan will be. When should I complete a fallout analysis? Before you're actually updating your life cycle cost for that particular part. And then what is the major benefit? Fallout can be a significant part of your repair budget, or replacing fallout is better said. You can get better prices on replacing that fallout if you have a plan to replace said fallout. Less time waiting for parts. Many a time we had to wait because we didn't have a plan A or a plan B in place to replace fallout, and or the fallout was a lot greater than we had expected. And then we can also obtain a more accurate life cycle cost analysis because we're using more accurate data in plugging in for one of the variables. The fourth key ingredient in our repair plan is choosing the right repair partners.
I think we move forward a slide, Greg. Need to back up one. Okay. Well, there's a number of ways to do this. Partner evaluation. Matrices are typically made in supply chain groups as well as repair groups, looking at the various vendors. And what does it really come down to? A background with that shop and your relationship. Do you have a general quality record? What is the history? You have 4 shops. Different shops have different quality records, and you can rate those and use them in your analysis. Your previous experience with working those vendors. Do they provide quotes and it's a hard quote and you get the same thing every time? Or do they add other things to it? Speed. Which shops get the job done on time? They tell you it'll take 4 months, it takes 4 months. They tell you it takes, a year, but it takes 2 years. When you're doing your repair analysis, it's also telling you your inventory level. Certainly if you have more than one engine, which, there's our past experience, we had a lot of engines, we had to turn inventory. It was a major goal for us. How much inventory on the shelf, and could you turn that inventory? So instead of having a lot of nozzles, buckets, stuff on the shelf, what's the minimal inventory we could have to do schedulized maintenance? And then we knew we had forced outages, and you have another level of inventory for schedule, another inventory for the forced outage, fallout, things along those lines. So a little bit more complicated when you have a lot of engines versus maybe having 3. The other one was experience with the engine. There's a lot of shops that have a lot of expertise in a particular engine. However, a lot of the same skill sets. If you're really great on this OEM, can you work on another OEM? Yes, but the alloys will be different. The way those parts are designed, fit up, upstream. So the philosophy of one OEM doesn't necessarily mean that it transfers to another OEM. If you have the other issue is parts experience with the engine, safety standards, And then also customer interfacing, TOs, terms and conditions, meeting the OEMs, meeting your company's supply chain management requirements. Do they meet this, or is that a negotiated settlement to find common ground between the two of you? So with a lot of these basic attributes you see on here, you can have a grading program from 1 to 9. And then from there, of course, price is always important. But knowing the value of all the, here we go. This is the sheet I've been talking to. why we were missing it. But anyway, this is the sheet I've been talking to. You look at the attributes, because that's part of really the value in it versus the cost. Cost is part of the value, but having parts delivered on time, being done correctly, a lot of experience knowing what you as a customer don't know, but the shop does. You know, you're getting a value from experienced repair houses versus something else. And so that kind of leads to the next slide, Greg, and then we'll look at the questions we had here. But there's certifications and the rest of it, warranty coverage, you know, what does it take? And it'll come down to a relationship between whoever is the key point guy from the plant or the repair group and those repair shops to follow up and see what you're getting going on. So you have a large fleet to draw from. How can an owner of 1 or 2 units have a comprehensive fallout plan? Part of it is going to, when you only have 1 or 2 units, or you're locked into an LTSA, you really can't see behind the curtain for, you know, you paid $1 an hour. So you really don't get to see the fallout. You have that. When you're in charge of maintenance yourself, you know, it's going to be experience. So the long-time answer is, you know, you go to repair shops, you see what falls out or not, what comes back from the OEM, you're going to know because you're buying parts and writing POs. You know, the other big part is we always participated in users groups, whether it was 501F, 7FA, EA, 6B. I mean, we've, you know, been fortunate enough to have exposure to all these engines and belonging to those groups and being both Greg and I ex-OEM. We've always had a lot of experience, as well as picking up the phone call to other people that had large fleets and we only had 1 or 2 engines maybe. You know, we kind of from our experience, or I called another user that had a bigger fleet and talked to them on the phone. They'll give you some general guidance. They may not give you exact numbers, but they'll give you some guidance that'll get you started to you see what is the number yourself. Yeah, can I get a copy of the tool here? I think we just made this as an example as opposed to a hard tool, since this is a customer-driven deal and the attributes that would be important to you as a company and, you know, for you to get your stuff done.
And I might add one of, you know, 2 of the other attributes that I look for in when going out for or soliciting repairs to my components is the ability or the of a shop to say no. You don't need to be doing this for, you know, for these technical reasons. It doesn't make sense to, you know, to do that, or you are going to significantly increase your either your fallout risk or subsequently, you know, the cost of the repair if you want to take the chance on, you know, going forward with the repair. So saying no. It was very important to, you know, to me. The other key aspect or attribute was their technical depth. How adept were they at actually solving chronic or, you know, major one-of-a-kind turbine problems? There are, you know, I certainly interacted with the you know, the OEM, and their technical, you know, depth is typically greater than anybody else's. That's not true in all cases, but I guess what I'm trying to say is, you know, partnering with or knowing that you're not just going to get a work scope completed on the part, but you are going to you know, receive some additional technical benefit because you going through the, you know, the RCA or repair development or, you know, other, you know, technical you know, routes that you're going to take with the you know, the supplier. You can again, you know, see value in learning a hell of a lot, and then subsequently solving other, you know, chronic and more expensive turbine problems. We have a couple more questions that came through. How often should you review a given shop qualifications for your work? I think the right answer, it depends. It depends on what you are seeing in terms of life cycle cost creep and or quality issues and or the other personnel changes or other changes that can drive or increase your risk of not getting what you need to get from a particular repair vendor. Pete, do you have anything to add to that?
Because a lot of shops, if you only have one or two engines, you're typically only taking the hot gas path parts to a shop every 3 years. I mean, it would make sense, or you're going to send a hot path versus a combustion set of hardware to a shop. You'd review them in the year before you send the parts to that shop, because you are evaluating not just them, other people. And part of that evaluation is, do you have spares to make up? And if you do have used parts, what's the background of what? So if I have a fallout, or do I have to, go to the OEM and have spares? Or, we were fortunate enough having a large fleet. We always had mixed sets to do makeups. I didn't have to, really rely on third-party shops for parts. Coupons, on vanes, leading edge, trailing edges, that was a huge definition of which shop it would go to. Because if I go to one shop, the OEM in that time level, they wouldn't do a coupon job. Their answer is, we either weld it, and if we can't weld it, then it's scrap. Well, third-party shops had coupons, and they had developed them, cores, sheet metal details. We could do all that. I didn't have to buy new parts. So when we were doing the life cycle costs, yes, the repair would be bigger if you're doing coupons. And that's only certain shops that had the technical capability to develop with a casting shop, casting new pieces, welding them in, and then proving them out in an engine. But kind of, the question of requalification, we could spend a lot of time on the topic, but it was, well in advance of before you would go to a shop and release work, or they weren't, you need to spend the time qualifying that shop before you would use them. And you typically know there's only 2 or 3 third-party shops that are typically qualified on certain parts, so you're going there as well as the OEM, and then you're making a choice. One of those 3 guys generically is going to get the work. You put your effort in spending the most time with them and whatnot. Well, have you ever seen companies pool together to purchase replacements? I haven't seen that. That doesn't mean it doesn't exist. I mean, the larger companies, as parts become obsolete, they sell their inventory. So those part numbers, while they're fine in certain engines versus the latest, greatest, whatever, those parts do go in the market. Do repair shops buy those buckets, unrepaired or repaired, and they go into the market? And then, you can know who was the last owner and call over there and talk to them. What is the story? Well, we did the .04 mod. We got rid of our .03 parts. We sold them to company X. There's spare inventory out there for you to buy versus going back to the OEM to get, whatever their repair is and their mod. So matching them up and putting your set together in moment weights, all the rest. There is ways to make that there are ways to make it happen, and probably far more today than what there was 10 years ago on a lot of these engines. The last question, maybe we leave that one to the end, Greg, huh?
Yeah, that's a good idea, Pete.
Yeah, okay.
A little bit of a loaded question, but a great question nonetheless. And then the 5th ingredient, a main ingredient in a good repair plan is starting your execution early. We've gone through, or with the first 4 ingredients, it's probably not something that can be done overnight. So starting our execution early to ensure that, we've covered all of our bases, know where our risks are, know our parts, know where we're going to, or what general direction that we're heading. Starting that journey early is of critical importance for several reasons. Or before I go into those reasons, when we're planning to execute, let's make sure that we have a PO in place. I'm laughing a little bit because there have been numerous times to where We've actually done work or had work done to our parts with no PO in place, and that just puts both parties at significant risk. Know what our witness points are or use technology. Just yesterday, we had a video conference with a customer and went through in significant detail the as left measurements on a set of parts. Worked extremely well, and again, it gives us the ability to to witness or perform witness checks essentially anywhere in the world. Give yourself time or have a contingency plan, just in case our fallout is greater, our parts are actually unrepairable, and or other issues arise during the repair planning process. And then have your internal and partner communication plans set. In terms of contingency planning or of those areas, having a plan B is absolutely crucial. We've talked a little bit about fallout risk or having a fallout plan. And when it comes to blades, especially after their second run, let's say they're a 3-run part or a 4-run part, you're typically going to, or you can anticipate having higher fallout. Or if you have an operational change like the industry experienced years ago when most units went from hours-based maintenance to starts-based maintenance, your risk profile for the engine and individual sets of parts changed. So, identify what your potential risks are. In this case, what our fallout is. What is the likelihood that my shop that I typically go to is going to have capacity issues? We know how quickly the world overall can change. We've all experienced the effects of COVID-19 and how that could potentially impact when I get my parts back and how many parts I get back from a repair vendor. So identify what your primary risks are, and then this slide shows just a tried and true method of identifying what your greatest risks are, the likelihood that they're going to happen, and then build contingency plans around those. So when we're when we choose our top 3 risks or potential risks, what are the potential dollars at stake? That will drive, subsequent behavior. How much time and attention do I need to pay to dealing with that potential risk? What triggers can we watch to know, and can we check to know if? In other words, when these risks turn into actual, events or impacts to your operation, what are some of the early warning signs? Be it, communication from your repair partner, or, what are other customers, experiencing? Know what those are so you can adjust your plans accordingly. What steps can we take today preemptively? Again, not to beat a dead horse about, fallout, because it is extremely important, but where can I, if I have, let's say 10% fallout on a set of 92 blades or buckets, where can I find those? Does the shop have them? Do I have to go to the OEM? Is there some other source? What steps can I take to avoid, being late in getting my engine back in operation? And then what steps do we take if signals, triggers, occur? We have the repairs complete, and we're short, 5 buckets. We'll probably, if we haven't already taken steps or done a little bit of research to identify where we can get those parts, where do we go from now? The steps are probably very similar, but could be slightly different. So overall, the intent of this part of the presentation is just to implore to everyone to understand, what your potential risks are of not having the parts that you need to go into the engine when you need them to go into the engine, and having a plan A and a plan B, and if necessary, subsequent plans, depending on the financial cost of if the risk does actually, become material. Now we have a few more questions that have been asked. What do you think of 3D manufacturing to replace individual small parts? I don't have any significant knowledge in that in that domain. Pete, do you have anything to add to that or a response?
Yeah, I mean, to me, it's kind of a cost. I mean, if it's certain parts, you would just sheet metal, stamped out, laser cut, whatever it is. Other parts, if it's a casting, it may work for like an end of a core or a pin or things along those lines that, if it is a cast part. I mean, the things, when you go to that kind of manufacturing, that's very small grain size parts. Grain size affects, material properties. Sometimes you want large grains in certain areas. Sometimes you want really small grains. Some it's immaterial. It's about, oxidation or temperature, and it's a feature that maybe holds something in place. So certainly, 3D printing would make sense in a lot of cases. Others, you may not be getting the right grain size when you manufacture that part, and you would, there's going to be different quality as far as voids and things along those lines. So it comes down to what the requirement is for those moments. So generically, I'd say it has its application, and picking and choosing when it works versus a piece of sheet metal or a piece that's machined out of, cast stock or whatnot. You want to hit the next one, Greg?
Absolutely. Next question is, how many months in advance of a repair would you suggest getting started on planning? My rule of thumb, or what I typically did, was as soon as the parts came out, I started my plan to either repair, retire, replace, etc., that set of parts. You don't necessarily have to go all through all necessary steps, but having a general idea of what the part condition is, running or updating the life cycle cost for that that component. Do all the other necessary data mining to understand, again, what condition the part is in, how much money we've spent, does it make sense to go forward, etc. So there's not an answer in terms of, a real number answer, so to speak. I can't say 6 months, can't say 3 months, can't say 2 years. It depends on when the parts are needed, as well as, other, aspects of your operation will drive that. But in an absence of an actual number, suggest starting as soon as you possibly can, at least on understanding or knowing the condition of the part at hand. Because you wait too long and you just pull a part out of a box, you might be able to repair it in time under normal circumstances. But if it's about the part or the part falls out, you may not have enough time, or you may have to delay your outage and wait on that set of parts. Oh, go ahead.
Yeah, really, we kind of seen a change with customers going to just in time. Where in the past, you had a plan before the outage. You kind of knew what you're doing. You might have a bid party walkthrough. You may have, hey, here's a preferred vendor. I have the best or the least amount of fallout through here. I know it's going there. So you have a price quote and everything before the outage happens, because it comes out of that engine. It's going to a repair shop the next day. It's got to get turned in so many months because it's got a home as soon as that repair shop's done, and then it forces an inventory level. So the question that's there is based on, if you have enough engines, do you have enough inventory? So you have a fleet of parts going in and out through parts, your shops, or you're a one-off plant in which you have an outage. Those parts aren't going to be used again for 3 years. It's not uncommon for some of those guys to, they have a plan, but those parts sit on the shelf for a year or two and get repaired, and they're, getting ready in year 5 for year 6 to go in an engine. They're not maintaining spares or whatnot. So to say a single number would be very difficult in this case. Depends on your site location, and then what do you need to have? You want to take the next question, Greg?
Focus on
Expert review.
Yeah, how important it is to have an expert review repairs at critical steps in the repair process. Can you give an example of what to look for in, let's say, the repair of the 7F first stage vane? I'll take the first part, and I'll let Pete take the second part. The answer again is it depends on the actual part and the risks of not having the part repaired to specification. In most cases, it's a great idea. It's not I would say mandatory or that important in all cases, but anytime that you can have additional oversight or additional input into the execution of your repairs, the better off or the better the outcome in most cases.
Yeah. And then I guess on my part, what would you be paying attention to? What's really important on those vanes, it's going to be wall thickness in areas, and those are tapered parts, so there's a tapered wall on them. So it does affect things as far as how many times has it been stripped. So part of my answer to you is on the INA, a lot of the critical stuff you're going to have to deal with happens on the INA. And then being able to review their data sheets in the shop, their work scope, and what that shop considers good or bad, wall thickness, distortion, area checks, things along those lines. That's kind of the first thing until you know those things yourself, whether you worked with an outside consultant or you have past experience from the OEMs or other engines, you're going to kind of learn that part. What is the distortion out of that particular engine, of which, there is differences between the engines in the fleet. You have problems with, air control coming into the plant, how much ends up inside my vanes. Things along those lines. And then you'll come to, before you go to coating, reviewing the heat treats that part is seen. What are your wall thicknesses now? We restored wall thickness, fixed all the cracks all the way through the wall, halfway through the wall, doing a review inside the cast, inside the parts and whatnot, and then reviewing all the sheet metal details that are going to it, the condition of those. And then at the end, it's going to be final dimensions, because you're fitting up parts. I don't know. Can't figure out. The fit up to transitions and also fit up to the shroud blocks in the case, and making sure you got your seal there on the row 1 nozzle. So there is a number of things till, using an outside consultant to help you so you know what you're looking for. A lot of shops have done, on 7Fs, there's no shortage of shops now that have done a considerable amount of nozzles. They put in the engines, they haven't had parts, versus a shop that it's their first or second one going through there. That's a different level of attention to detail. What do you need to know? Maybe you do need to have someone else with you to make sure that shop is doing everything they should, so they have the experience and have learned over time.
And I might add that depending on your permit requirements, emissions and subsequently airflow on your first stage segments is of critical importance. If your first stage nozzle uses too much air, you're more than likely going to have emissions issues, or you're going to have to burn some additional ammonia to stay in emissions compliance. So airflow is also a extremely critical parameter to ensure that the vanes are repaired properly. You have the right throat area, the right coating system. Everything is perfect, but the vanes don't flow properly. You can, have, issues that are severe enough to potentially force you to replace that part in the engine. Another question, or the next question is, I have been focusing a lot on fallout for rotating parts. Is that because most engines are assumed to be tuned and operated properly, such that there are a few issues from the combustion section? If so, what is the most common reason for rotating part fallout? It depends on the part. It depends on the design of the part, but you can have undershroud cracking, let's say on second and third, or shrouded rotating blades. You have that heavy mass that's rotating. It's pulling on the rest of the airfoil, and creep voids can develop. Some F-class technologies had for a long time issues with platform cracking. In some cases so severe that the entire suction side platform would disappear during operation. And then, the OEM have their specifications. Third-party shops may have their, have very similar or materially different specifications, such as, crack limits, where you can weld, not thinning, but issues on the, in the dovetail region, et cetera. So, again, it depends on the actual part, but the middle part of that question, because units are tuned and operated properly, there are a few issues from the combustion section, yes. Those issues are much more apparent and easy to identify with combustion hardware, and they've been such a high area of focus over the years that a lot of the more chronic problems or more expensive problems have been resolved. Not all of them, but a lot of them have been. Do you want to take the last one, or would you like me to, Pete?
I guess the last one is, what's the importance of the repair vendor seeing the parts when they come out of the engine? I mean, a big part of, Greg and I's experience in the past, and then working with repair shops, we were very familiar with those engines, what the parts look like in the engine. After certain repair shops, they fix them with what they look like after 1, 2, and 3 years, because we had a lot of bore scope inspections. So it depends on who from the repair shop is coming there to look at the parts. And if it's a well-rounded guy who understands the operational stuff, what it looks like there, and then what it looks like in the shop. Because, a lot of these advanced turbines all have, first 2 rows for sure have coatings on them, and sometimes rows 3 or 3 and 4 have different coatings on them. And they can hide some problems. I mean, big open cracks, leading edge blowouts, do they know before he gets to the shop how many leading edge coupon jobs you're going to do? You bet they would know right then. If you're on site, you see the roll 1 vanes come out or nozzle and an OEM, how many leading edge blowouts, which ones can be, welded up, which ones are going to be coupons. So you have an idea about money before you get there. But at the end of the day, they're going to end up doing stripping and NDTing and dimensionals. It gives them an idea and maybe a head start, because you probably do the same head start taking pictures of parts. If you're partnered with a repair shop or whoever, send them ahead of time and him to know versus traveling the site. But it does help. Other thing is, Greg covered a little bit earlier, a lot of this new airfoils have very small leading edge holes, tip cooling holes. So if you have inlet duct issues where that's slowly coming apart, the core tin in there and the rest of it, that's small particles. They end up a lot of times getting centrifuged into the buckets. Water injection, a lot of these things end up with some issues. Carryover from our evaporative coolers. That dissolved solids become a solid once they get to the airborne side, and they end up in your row 1 vanes, row 1 buckets. Row 2, that causes heating and then burn up, and then you burn off tips or trailing edges. It's very difficult to repair properly those parts and get the service life out of them. So it's a number of different things. It helps, guys in the shop to see the stuff in the field, because they get kind of focused. You're the guy in charge of the vane cell. You look at a lot of vanes every day. You don't look at the whole engine and see the interface. Maybe something else that comes out of that is the interface from one set of vanes to the next set of vanes or nozzle. You start seeing the fit up. between nozzles and blades. You know, we've seen a huge thing where people weren't doing the areas correctly. They're shifting the areas out as the parts creep downstream. They tip the parts. Really putting the airflow geometry back into the engine so it's hitting the blades correctly. You know, those kind of things get obvious when you roll a set of parts in the engine that I hit dimensions like I should have, is your drops, and it's your areas, and it's your, you know, interface of how the flow leaves the nozzle or vanes going to your buckets or blades, and then leaving them going to the next one. That stair step through your engine. There's a couple of things that come out of being on site and seeing the whole engine together as well as coming apart. What does it truly look like in that repair process? Okay. I don't know. You want to
question regarding oh, go ahead, Pete.
I'd say get rid of your let's get rid of our last slide, and then whatever questions we have, and you know, we're getting close to our time too.
Again, as far as our additional step on contingency planning is create your action plan with owners, timelines, and milestones. I'm not going to go through this in detail. It's fairly self-explanatory, but I do want to highlight again here are listing all of the potential actions to deal with our fallout risk, and then what the triggers, who owns it, the timing, etc. The more robust your plan B or your contingency planning is, the less likely you're going to be left stranded. I typically use more than one triathlon analogy anytime I'm speaking, but this is it's similar to taking more than one spare tube. If you have a flat at the halfway point, what's to say you're not going to have another flat later on? And if you are 50 miles from home, it's going to take you a long time to get home walking that far. So the better your plan, whether it's having additional parts, it's having access to additional parts, or another solution, having it is what matters. The next question that was asked was, you mentioned vendor comparison. What are your thoughts on bid processes, bid walks? Are they worth the effort? What tricks should be aware of? Should we be aware of? My answer is I'm a strong proponent of bid processes and bid walks, primarily because you can learn about capabilities, learn about other attributes that are going to either eliminate or mitigate risk or add to your risk. And you say, well, with COVID-19, it makes it next to impossible. We just completed a repair of a set of parts yesterday that were awarded during a bid walk, be it at our facility or somebody else's facility or at the customer's facility. I'm a strong proponent of having that for our benefit, but more importantly for our customers' benefit. Pete, any tricks that we should be aware of? Or?
I mean, it's a lot of common sense things, right? Everyone, when they're giving you back quotes afterwards, you do the bid walk, would they do the same INA methods? And to a certain point, it's kind of something you work out ahead of time, because you can get 3 quotes ahead of time for your inspect and advise, review those quotes and what are they doing, talk to the 3 of them, you pick somebody for various reasons. You get to that point, INA is done, so dimension sheets, that vendor's got to be willing to share that with the other 3 guys or the other 2 guys or whatever the number is. And then everyone goes through it. And you'll get feedback at that point from the other shops on how well or not that they've done at that point. And then you're going to see the feedback from your various vendors. I mean, you're going to learn a lot during this process. Yes, are you spending money on airfare? If you're not in Houston or somewhere else, you're going to have to travel to make this work. Some people, like Greg said, today's date are doing everything with FaceTime and a lot of other methods to make this happen. Fine, that's where we're at today. and then going through and then picking the vinyl vendor. You got a price and that. The things that are hard afterwards. So what are the tricks? Someone bids low, and then you get scope creep. You know, being very clear with people that, hey, I need the price, and then if there is fallout, I want that in my bid. If this happens, I want that in here, so I know that vendor A, if I have fallout, he can provide it, or coupons. You know what that is ahead of time. So the first time a lot of people go through it, does it make sense if you don't have an internal staff guy that knows these parts inside and out to have an outside guy to help you with it? Because if you're on an F machine, this is not insignificant money, and the amount of money to having someone to be there to teach you the first time to go through these things or to review afterwards is, you know, I would say very well money spent. All you got to do is buy a couple of new roll one buckets, and you spent far more than what that consultant helped you with getting through the process. They'll also help you with the bid walk and that. I'd say the biggest thing as far as tricks has been, you know, customer complaints that I've heard from a number of places. You know, we thought our number was here and now it's moved to here. You guys gave me a number and it stayed that number. What happened? Okay, that's fine. But, I don't want to be on negative there, but what happens is usually when you hear about someone unhappy, if they can't, a shop couldn't take care of fallout, which is important because now you have incomplete, you got to source it, or, timing, they didn't get done on time, you gave it to a guy, but it didn't meet your schedule, or, scope creep as you go through the process because they haven't done 100 of these and they pretty much know if you've done a lot of certain parts, you know what you're going to find or what's going to happen on a portion of them after heat treat, they re-crack again. That covered or not covered, and what do you do? So,
Whose data sheets do you fill in for us to, to check OEM, non-OEM, owners, operators, your own? What is your recommendation preference? I don't have a one single preference, and I think the standard answer is it depends. It depends on who you're interfacing with. It depends on partly on the type of the life cycle cost analysis program that you have. Other tools such as your CMMS system. Again, there's a lot of dependencies and specific to your operation. To the parts that you're operating in your machine, you could be filling out two different sets of forms. If you have OEM parts running alongside OEM parts, there's a lot of engines that are operating that way. So my recommendation is to do what works best for you given the constraints or the variables specific to your operation. I know that may seem a little bit vague, but again, there's a lot of different combinations of parts that are running in engines, which may seem complicated on the the surface, but if you're tracking and following your life cycle cost of your individual components as well as your engine, your parts as best as humanly possible. You choosing the right shop that can also help you figure out which forms to use, what data is important, what data is not important. You have a fallout plan, and then you have an execution plan. Then you can rest assured that you're more than likely acquiring, managing, using, analyzing, and writing down all the appropriate data and information. And now we can certainly open it up for additional questions.
Thanks so much for the presentation. If there's any more questions from the audience, I know we went over quite a bit today, just put them in the chat and we'll take care of them right now. I believe there was one question we didn't address before on industry turnover and how that's affected shop capabilities.
I guess I could take part of that. I mean, whether you're an OEM, third-party shop, you know, people get older, there is turnover. We see a lot of turnover in Houston shops. There's been some acquisitions of different companies by others, so they got acquired, and so that's changed some. There's less choices today than there was in the past. So you kind of see that going on. You see some older guys retiring and moving to different roles, so that's happened as well. So, you know, shops are always changing. In the past, you know, in my previous roles, we never had a single shop do anything for us, whether it was an OEM, third party. There's always 2 or 3. We were fortunate enough to have a large volume of parts. So we always have more than one shop qualified to do anything we did. There's a few exclusivity things in there, of which, you know, the OEMs did have some exclusivity. And did I deal with people changing out who ran the cell or ran those divisions, or they closed that shop and moved it to another part of the world where it used to be close and then it moved. So these things say that there's going to be change in shops. It's always going to happen. We still have people working at them. People get older, people change industries, they change jobs. So, you know, there's all the different cases in Houston of all the changes. Acquisitions have happened quite a bit. That's really helped a lot of shops. They've grown in a lot of ways. You know, a lot of shops, when they get big, it makes an effect because they have overhead and whatnot. So that can make some changes. And, you know, big companies put a lot of restrictions on, you know, how far you go and whatnot. So it's not good or bad. It's just what it is. And people react to it. Small shops, small groups, different exposure, you know, 1 or 2 key guys left. Can it make an effect? Yeah, it can make an effect. But, you know, a lot of the work that gets done is done by the guys on the shop floor. How many things changed there in the past? I had great confidence in shops that made big management changes in the front office. They weren't the ones that, you know, were the ones welding my parts, forming my parts, machining. His guys on the shop floor. So a lot of those shops, it really didn't change that much to me that the ownership changed. It might have made more effect to me the terms and conditions or warranty and some of the other stuff that changed to me over time. But the guy welding my bucket for blades was the same guy, and I knew that I had a high non-fallout risk when he was doing those repairs. So, you know, I guess that's a generic answer to you guys on that. Is there going to be changes in the Houston market? Yeah, it's been changing for 30 years that I've been in, and it'll be changing the next 30 years.
Yeah, and my only add would be, you know, the impact that I've seen as a customer is the speed at which some of the shops can actually operate. There are instances where speed is critical, and again, as these shops get larger and there are fewer of them, just think of it, you're trying to flow, more parts or the same amount of parts through a fewer number of shops. You could have capacity and or speed issues. So it's just something to consider when you are deciding who you're going to partner with for your repairs or a repair of a specific type of component. We're good at a lot of things, but we're not good at everything, nor is any shop good at everything that they do. So again, something else to consider when you're going or you're developing a repair plan for your components.
I don't see any other questions coming through on the chat, but I would like to tell everyone that we'll be sending out a video recording of today's presentation that you can share with your colleagues. And just wanted to give a special thanks again to TRS for today's great presentation and sharing their knowledge with us. And we hope you got a lot out of it. Thank you so much, Greg and Peter.
Thanks for having us.
Yeah.
All right. Thanks, Scott.
We'll see you soon, hopefully, when things get back to normal. Have a good one, everybody. Thanks again for attending.